My name is cont'd Genius, and today we are going to be starting with Module 1 on Machine Learning and Python in R. Actually, Machine Learning and Data Science in Python and R. Today we are going to be taking the introduction and course overview. Now, if you have gone through some of these course overview topics, maybe you can skip ahead to maybe the next 10 minutes into this video. If not, you can just follow through from the beginning of this video right to the end. So this is what we are going to be covering in these few minutes. We are going to be looking at computer specification, application and tools required, objectives of this course, how the course is arranged, sources of information, delving into branches of AI, exercise 1 and solution, and preview of the next class. And also remember that for every module, there is going to be an exercise and solution. I also like to mention that by now, I believe that you have this course outline. This course content is made up of about 40 modules or 41 modules, and hopefully within the 6 to 8 weeks between August and September 2019, we are going to be covering everything we need to know about machine learning and data science. And of course, this is going to be a highly practical course. So when you have the tools set up on your system, we are going to continue working with these tools and doing the necessary practicals you need to know. So let's quickly get into the first part. So basically we have computer and network specification. If you are going to be joining this course, since it's a web-based course, you are going to need a good computer and a good internet connection as well. So I recommend having something not less than 4 gig of RAM, because at some point we'll be working with graphics and also a good hard drive size, good processor, maybe Intel Core i3 or higher, i5 recommended, and application and tools required. This we are going to be doing in a different module where we are going to be setting up everything specified here. So we are going to actually be using Anaconda. Anaconda is a distribution of Python. So when you install Anaconda, you have Python 3.6, you have Jupyter Notebook. Now you also have this application R. So to install this, you also need to install R Studio, and this is another application used for data analytics and machine learning. We are going to be using Microsoft Excel, the good old Microsoft Excel. We are going to be using it. The reason we all need Microsoft Excel is because many of the data you receive as a data scientist or as a machine learning expert is going to be coming in spreadsheet format. So how do we use Excel kind of to convert to another format where we can now import it into our application like Python, Jupyter Notebook, or R, or MATLAB, as the case may be. Then we are going to be covering several libraries. I've listed a few of them: matplotlib for plotting, scikit-learn for clustering, contains algorithm for clustering, regression, SVM, support vector machine, and so on, pandas for data manipulation and analysis, and we have scipy for optimization, linear algebra, calculus. Then we have additional tools, RStudio, I've mentioned it before. We have JetBrains, PyCharm, because you actually need to learn a bit of programming. So when we are going to be actually learning bits of Python programming, we are going to be using JetBrains, PyCharm. And this is an IDE. Sometimes some say it's the best IDE for Python programming. Another important library is TensorFlow. Actually, it comes with Python as a module that can be imported into Python and used to analyze tensors or high-dimensional matrices. The MATLAB, as a time permit, we are going to be also using some tools in MATLAB. So the next thing we are going to be talking about is objectives of this course. What really do we want to do in this course? I know some persons have spent some time paying to learn data science and machine learning. At the end of the day, they are not able to do anything much with the knowledge. The reason is because the clear objective was not, they don't have a clear objective in mind. Now there is this hype around data science and machine learning. Everybody wants to get into data science and machine learning. But the question is, what are your objectives? What do you want to be able to do at the end of the day? So let's clearly highlight what this course is all about in this very slide. So one, you need to understand, have a good knowledge of artificial intelligence, know what artificial intelligence is and what it is not. Also have a basic knowledge of programming and be able to manipulate data using Python. So instead of using tools like SPSS, which is a proprietary and expensive tool, or MATLAB or some other tools, you should be able to write your scripts to manipulate data any way you like. So you are not limited to what an application provides. So you are not limited to importing data into some application and waiting for an output to come out. You have to write your model, your own script to be able to analyze your data. You also have to develop skills in modeling applications, including Jupyter Notebook, R, and RStudio. You should have skills of using this application very effectively in managing data. Then you need to have a theoretical knowledge as well as practical knowledge of machine learning tasks. For instance, you should learn about what does it mean to pre-process data, what is a regression analysis, what is classification, how do you use it to get information and insights from data, cluster analysis, model selection, model complexity, bias and variance trade-off, and so on and so forth. These are concepts that you need to know as the basic concepts when you are studying data science or machine learning. Further objectives include you have understanding on strengths and weaknesses of major popular machine learning approaches. For instance, you can use two different particular approaches to solve a problem. For instance, you can do dimensionality reduction using principal component analysis. You can also use factor analysis. You can also use singular value decomposition. How do you determine what is the best approach to use for your data? This you also have to learn in this course. You also appreciate the mathematical relationships within and across machine learning algorithms and the paradigms of supervised and unsupervised learning. And then you'll be able to design and implement machine learning algorithms in Python and use them in a range of real-world applications. For instance, I have a student who says he wants to do a research in carrying out sentiment analysis on tweets generated in Twitter. So the first thing, he had to mine the tweets, generate the tweets as a large data set, and be able to perform analysis and classify these tweets into categories based on sentiments that has been deduced. So you should be able to do this to apply machine learning algorithms in real life application. The courses are arranged in this way. There will be instructors for me, Dr. Ndukawonu, and there might be other persons that may also take parts of this course. So there will be 4 hours per week, 2 hours per class, so 2 sections in a week. So in a week we have 2 hours in one of the weekdays and 2 hours in another weekday. It will be an instructor-led, interactive, and also lab. So if you have challenges, you can actually reach out to one of the instructors and have an interactive section with this instructor. There will also be labs and hands-on. There will be procedure provided, and we are going to follow these procedures to solve particular problems. There will be additional information, like there will be weekly practicals, there will be exercises or assignments, and there will be personalized assistance, and there will be group project towards the end of this program. Alright, so we also have sources of information. There will be presentations in PowerPoint that will be provided. There will also be video lessons that will be provided at the end of each week. And complete solution to the labs will be made available in the following week after the lab. So this is how this course is arranged. Hopefully you'll find it interesting. And let's now start talking about artificial intelligence. Now, when we say something is intelligent, it means something can act with some reasoning, right? So you don't just do things, you have to think before you do it to make sure you do things in the right way, or to make sure you make a choice, a rational choice, different from how a lunatic will behave, doing things randomly. But well, this definition, there are a number of definitions about intelligence, especially artificial intelligence. I've outlined 4 of them that we can actually relate to it. That is very clear to me. And one of them is the one made by Bellman in 1978. He says, the exciting new effort to make computers think, machines with minds in the full and literal sense. So again, we have the word think. What does it mean to think? You have to look at options and make a choice of what to do. So in this way, computers should be able to look at the environment and make a choice on what to do. So that is what Hengland, okay, yeah, that is Hochland in 1985. So Bellman in 1978 says automation of activities that we associate with human thinking, activities such as decision making, problem solving, learning, and so on. Then we also have this one in 1992, which is also of interest to me. It says study of mental faculties through the use of computational models. So when we're talking about mental faculties, we are talking about humans. But now, instead of applying it to humans, we are allowing computational systems to have some element of mental faculty like humans. Later on, when we talk about neural networks, we will see that computational systems are modeled the way biological systems like the human brain is designed. Then we also have Winston in 1992 says the study of computations that make possible to perceive, reason, and act. So basically, humans have to think and then act rationally. Then we also have acting humanly, acting rationally. All of this is about relating to the same thing. So what are we talking about? We are trying to make machines, systems behave in a way generally humans will behave. So that is what artificial intelligence is all about. So what makes up artificial intelligence is a subject of debate. For instance, when you can communicate with your phone, tell your phone to translate, and it translates. Can we say that is intelligence? Or when a phone receives a call and is able to a call comes in and a phone detects that you are driving and maybe asks a question and things like that. Or what if we have smart devices? At what point can we say they exhibit artificial intelligence? So these are subjects of debate that we are not going to be getting into at this point. But this guy here called Alan Turing tried to develop a test for intelligence. This is not the IQ test. So this Alan Turing is a computer science scientist from England. So he's known for his work in developing algorithms that cracked the German ciphers, the Enigma machine, in 1944-45. During the Second World War, the English were able to crack the German codes and be able to listening to the German communication from the British from England. They were able to listening to the German transmission of messages between their submarines and so on. So this was done by this guy Alan Turing. So this guy says that there can be a test to test if a machine is actually intelligent. Now, to be called intelligent, a machine must produce responses that are indistinguishable from those of a human. So let's say you are making a phone call and an answering machine picks up this phone call and starts communicating with you. If you are not able to distinguish that this is an answering machine and you think that a fellow human is talking to you, then we can say that machine is intelligent. So that is what Alan Turing is trying to say, that if you cannot differentiate between a communication between a fellow human and machine, then that machine that kind of fools you to think is a human is intelligent. So let's look at an example. I would like you to take some time to read up about this man. He's an interesting man, especially how he died. He committed suicide, and especially how he was received in his own country. He was actually not well recognized in his own country, despite all the works he has done, and eventually died at a young age. So that's the irony of it. For many researchers and many inventors, it's very sad they end up in this way. So computers need to possess the following capabilities according to Alan Turing. Natural language processing enables them to communicate effectively in a particular language. Knowledge representation to store and know what it hears, more like memory. Automated reasoning, and machine learning, right? So we are going to talk a little bit more about machine learning later on in this presentation or later on in subsequent modules. So now let's take an example of how Turing test works. So we have a human communicating with a machine somewhere, but he doesn't know that this is a machine. So he asks, what is the purpose of life? So the machine responds, to serve greater good. What is the purpose of living? To live forever. So it tends to be making sense at this point. What is the purpose of existence? To find what happens when we get to the planet Earth. It's kind of being funny at this point. So it says, where are you now? I'm in the middle of nowhere. So at this point, the machine kind of starts failing gradually. At this point, you should know that this might really not be a friend or maybe not a human. What is the purpose of dying? To have a life. And you see, it kind of seems to be automated. So for me, if I'm trying to take this test with this machine, I'll say this machine is not intelligent. What is the purpose of being intelligent? To find out what it is, and so on and so on. So this is how the Turing test is. So we have this machine that tends to be not so intelligent, and for me, it actually fails this test of intelligence. So this is about Turing test. Alan Turing, his test for intelligence. This is how it goes. So in case, what does it mean that a machine is artificially intelligent? It's a subject of debate, but Alan Turing came out with the Turing test that can actually be used and has worked actually in many cases. So we have a few foundations of artificial intelligence. There are about 8 of them: philosophy, economics, mathematics, neuroscience, psychology, computer engineering, control theories, and cybernetics and linguistics. I'm not going to spend time to read out all this, so I'll allow you to spend some time to get used to these definitions and what they're all about. So you try to connect how artificial intelligence is related to philosophy, mathematics, and all these subjects mentioned here. Alright, then the next part is, what does it mean learning? Because after now we are going to be going to machine learning. Incomplete information about the environment. Okay, so now we have these points mentioned here. Why do we need to learn? In artificial intelligence, why is learning necessary? The reason is because as you move on, as you explore more grounds in the environment, there are new grounds or new information that comes in. So if a machine is programmed to have only one set of information, for instance, a computer CPU and memory and hard disk, it doesn't make no sense. The computer should be able to acquire more information as time goes. The CPU should be able to improve itself in performance as time goes. So learning is necessary because we have incomplete information about our environment. We also have a changing environment. So what the environment is in 2019 is not the same as what it is many years ago. We also use sequence of percepts to estimate the missing details. Hard for us to articulate the knowledge needed to build AI systems. So we keep learning new things. We try writing a program to recognize visual inputs like various types of flowers. That will not be easy, so it requires continuous learning. So the question is, what does it mean to learn? Learning in AI is not exactly the same, or is related to how we learn as humans, but not exactly the same. So here learning is in a broad term or a general term that denotes changes in the system that are adaptive in the sense that they enable the system to do tasks drawn from the same population more effectively and more effectively, more efficiently and more effectively next time. So this is going to become clear as we move. So if you take some sample from a population, perform some statistical analysis on this sample, it tells you about the underlying population. Now, when you draw more samples and perform another test, you have to receive additional information or a more refined or a more accurate information about this population. And this might be irrespective of the fact that this population is changing. So if you calculate, if you build a system that tries to understand the population of people in Africa in 2019, if that is a machine learning system, then way back, well, in time 50 years to come, that machine should be able to understand the new set of population existing 100 years to come or 50 years in time, because it has to be learning as time goes. All right, so we also have classifying learning problems. So these are the three aspects or three classes of learning problems that we are going to be working with. We have supervised learning. Supervised learning means that you have a set of inputs and output pairs, for instance, X and Y, where Y is a function of X, or Y is a function of X1 and X2. So in this case, in the traditional statistics, we say dependent and independent variables. So here we learn to predict the output if faced with new input. So you have X1 and X2. What is Y? You apply the function that relates to two. But in machine learning, you are actually not going to be given these functions. You are going to make sense out of the data set. We have unsupervised learning. Here we are trying to learn patterns in the input with no specific outputs or values supplied. So in this case, you have only X1, X2, and you simply make some sense out of it. So basically, we are flying blind. We don't have any output. We simply have series of data with no corresponding output. And we have reinforcement learning. So in this case, it's applied mostly in game playing, where series of steps leads to an output. So series of related inputs leads to an output. So we learn to interact with the world from reinforcement you get. So if you are playing a game, when you win is not when you are making the right moves. You win only at the end of the game. So if you are making all the right moves in a game, but you end up at the end of the game losing the game, then that is where reinforcement learning comes in, because your output, whether you win or you lose, should depend on series of inputs right from the beginning to the end. So here we are talking about sets of related values in this case. Alright, so let's move on to application areas of AI. I'm not going to be reading this. I'll allow you to spend some time to read it up. We have robotic vehicles, speech recognition, autonomous planning and scheduling, game playing, spam filtering, logistic planning, robotics, machine translation, and a few more. Alright, so what are some of the dangers of artificial intelligence? Well, automation putting us all out of work. Well, this has actually been happening as millions of jobs have been lost through automated systems. The number of the number of employees that work in a bank has systematically reduced over the past few decades to a very much minimum at this time, and this will continue for many other tasks. We have lots of human control of our lives. So loss of human control of our lives. So robots that surpass human in strength, speed, agility, endurance, decision-making, intelligence, and so on. So you actually lose the control. For instance, if you have a home that is automated, you have a system that regulates the temperature of the home. You don't have to regulate the temperature. You have a system that controls all the doors that open automatically, closes automatically, locks automatically. So basically, you are losing control. We lose control of everything. We know about the case of Boeing 737 MAX. So this plane has a system that tends to switch on the autopilot at some point, and override whatever the pilot in the cockpit is doing. So, and at some point there are a number of plane crashes due to this system malfunction. So when we have control have been shifted from humans to the system and something goes wrong, it will lead to maybe loss of lives and a whole lot of other negative things can result. So in future, there's also the fear of killer robots. So if robots are able to learn how to reprogram themselves or how to create more robots, what if robots are able to create an army of robots and decide that humans are a nuisance to them or humans are useless and decide to wipe away the human race? Well, this sounds like science fiction, but who knows? These are some of the dangers of AI. Robot emotions, will they have empathy? Well, no. For now, they don't have. So they don't exhibit any emotions. They just do things in one direction. And we also have, will their goals evolve in a negative direction? Everybody knows everything. So when there is knowledge everywhere, how do you control which information gets to the right person and who have access to which information? So these are some of the dangers of AI that we are concerned about. At this point, we are now going to do the exercise one. Now, this exercise actually assumes that you have installed RStudio in your system. If you have not installed RStudio on Python, actually RStudio, download and install it, or you can actually keep this exercise pending till module 3, where we install RStudio and Python. So here we have Open RStudio, examine the dataset available in ISLR package, export the detecting dataset in the ISLR package to CSV, place all the datasets in a local folder in your computer, and for each dataset, complete the NP column of the table below. So this is the table, and we have all these datasets, and I want you to complete this column. So at this point, I'm going to follow through on this exercise. Now, this is the solution to this exercise. So let's just go through this exercise at this point. So I'm going to open RStudio on my system. So let's see, let's see a second. Okay, so I have it displayed in the second monitor. Anyway, I'm going to open it all the same. So this is the RStudio window. So at this point, we are going to follow through on the exercise. So this is RStudio that's just opened. So I'm going to just press Ctrl L on my keyboard to clear the screen. So it says we are going to look at the ISLR package. So to get to the ISLR package, just come here. You can actually type ISLR or just go to packages at this point. So you have files, plots, packages. So go to packages and choose ISLR. Scroll down and look for ISLR. You can see right here. So I'm going to just click on install. I think maybe I can just type ISLR in this place. And I'm going to just say install and say, as I've installed it, so well, it's installing a second time. So at this point, the ISLR package has been installed. The next thing is to import or export all the data sets from the ISLR package. So what are the data sets in here? If you click on ISLR package, you can see that there is a number of data sets in here. We have the auto data set. So to check what is in the auto data set, you simply type fix auto. It's going to give you information about this data set. So if you press enter, it's going to give you this window, right? All right, so at this point, we now want to check, because from the assignment, you need to learn about the shape of this data set, what this data set is all about. So to do that, I think you can say dimension auto. Dimension auto, it says 397 is to 9. So if we go back to the tables here in our exercise, sorry, let's go back. So for auto data set, we want to fill 397 by 9. 397 rows, 9 columns. So let's get back. The next thing we want to do is to export this data to the system, to our local computer, because we are going to be importing it into Python. What I'm going to recommend for you to do is for you to maybe go to your computer and create a folder on your computer. If you have a drive C or drive D, you can just go to one of the drives, maybe your drive C, and create a folder. For me, I can just do it in my drive D and create a folder. I'm going to call it datasets. Datasets, right? So I'm creating this folder in my drive D, and this is where I'm going to put all the data sets I'm going to export from R. So if I go back to R, I'm going to export this auto data set onto this folder in my drive D. So to do that, I'll simply say write.csv, and then I specify the location of this folder where I want to write this file. So I'm going to just say d \datasets, because this is the name of the folder, and it's going to be auto.csv. Alright, so but before I do this, I'm going to just view this data set again. Let me just view it. So if I say auto, so okay, so perfect. Control L. So this is how to export these data sets as a CSV. So if I run this code, it says it exported actually to my drive D, to that place, the folder. So if I go back to that folder and I open it, you can see, okay, we have a challenge here. So it says 1D data sets. Let's see, I think it should export. So this is the folder datasets. So let me refresh. Okay, so it did not export. So we have write the CSV. Okay, so let's get back to the presentation to see if we are missing out something. Okay, so we need to specify the name of the dataset, and then before we specify the location. So let's just get back to do that. So the first thing we want to do is the name of the dataset, auto.c-auto, and then specify the location. So this is the syntax to use. So so you say cannot open file the dataset, no such file in directory. So let's go back to the presentation to see if we are missing out anything. The dataset auto.csv. Okay, so let me see. Write the CSV, the auto.csv. So let's see. Cannot open file. Okay, so write the CSV. Okay, caravan the CSV. So actually the name is datasets. The name of the folder is datasets. So you can see it's not just dataset, it's datasets. So that is some little mistakes that can be made. So let's correct it. Datasets auto.csv. So I'm going to just run it. Good. So at this point it exported to my drive D as auto.csv, as you can see. So if I open it, So open with Microsoft Excel. You can see that the data set is exported. Okay. So this is how to export data to CSV. So that is what you need to do for all the other data sets in R. So we have about 13 data sets, maybe, I don't know. So I export Caravan and every other data set into this folder. Maybe we can just do for one more. So let's try caravan.csv. So it's going to be Caravan. Right, so just run this and we've exported a second data set. So this is what you should do because we need all these data sets for us to continue working with them in Python. So this is how to work with exercise 1, and then next class we are going to be looking at review of some relevant maths topic, and I'd like to see you in the next class. Feel free to reach me if you have some challenges following these lessons. I'd like to thank you for viewing, and we see you in the next class.